Hi class, let's take a look at example 2. So the difference from example 1 and 2 is that in example 2 they want you to evaluate. So in this case they're going to give us an actual polynomial, and what they want us to do is basically evaluate, in this case x is equal to -1 and y is equal to -2 into the expression or the polynomial, and then simplify it as much as we can. So what I'm going to do first is I'm just going to rewrite the original expression, but with parentheses on all the variables. So technically you still have an x, y, and then minus a 2x, and then careful on this one because we have a y to the second. And then all we have to do in the next step is into the actual polynomial, we're going to be evaluating for the x is -1 and for the y is -2. So in this case, the x is equal to a -1 times your y is a -2 minus a 2 times an x is a -1 and your y is a -2 to the second. Whoops, let me fix that portion there. So as we actually simplify this one, I'm going to multiply first the -1 and the -2. So this expression, it's going to be equivalent to the following. So we're looking at this is equivalent to a 2 minus a, technically a 2 times the -1 times the values of a 4. Now, careful on this portion here, and I'm just going to do it on the side. It actually represents -2 times -2, so this is equal to a +4. And then at this point, what I'm going to do is I'm just going to multiply those two. So the actual expression is equivalent to the following. So this is a 2, technically plus a 2 times 4. Or we're looking at this is equivalent to 2 plus the values of 8. And our final answer is going to be that this is 10 as our final answer. Let's take a look at example 3. Now, example 3, it's a little bit different. It's one of those solve problems. So solve means which x value actually can you plug in both sides of the equation if the equation has an actual solution, and then you're going to get a true statement. So the problem only says solve, and remember that when we're solving these problems, you're supposed to simplify both sides. So in this case, simplify the left and the right. Nothing to do on the actual left, so I'm just going to rewrite it as 2x minus 4. This is equivalent to the following. And as we simplify the right hand side, we're looking at on the right, you're going to get a -x minus a 4. And remember that solve means you're looking for which actual value you're going to get a true statement which represents the solution to the problem. So let me first put the x's in one position. So in this case, plus x and plus x. And that actually gives us, and let me move the problem here, the value of 3x minus 4, which is equal to a -4. And then our next step is going to be to add the 4. So we're going to end up with the values of 3x is equal to, in this case, -4 plus 4 is equal to 0. And then in the last portion, we're going to be dividing by 3. So we're looking at x is equal to 0 divided by 3, which is equal to 0. So in this case, our final solution is that x is equal to 0. So that would be the actual value that if you plug it into the original statement, you're going to get a true statement for both sides of the equation. Let's go to problem B. And if you look at problem B, as you attempt to solve it, it has an actual problem on its own. Let me explain. So as you try to put the equation in a format of x is equal to, so you're looking for x is equal to a specific value, well, your first step should be to remove the x's or put the x's in one side, and that creates the following problem. As you rearrange the x's, you end up with, well, technically -1 is equal to -3. And in this case, this happens to be a false statement. Because of the false statement, your final answer, it's going to be a no solution. So in this case, it's going to be the empty set or no solution. In this particular problem, and then you can actually say both of those, empty set, no solution. In this particular problem, no actual value that you plug in, it's actually going to give you a true statement for the original problem. So this is a no solution one. Let's take a look at problem C. And problem C, it's slightly similar to the previous one, except that we're looking for the following on this one. On the left, you have 10x minus 1. It's equivalent to, well, technically 10x minus 1. And when you attempt to remove the x's from one side, or in this case, well, put them on the left or the right, your x's disappear and you end up with -1 is equal to -1. Give me just a second. So -1 is equal to -1. And remember this particular case, in this case, this is true. So because you end up with a true statement, you would actually say, well, infinite amount of solutions. Or if they want it as a set, in this case, you can rewrite it as a set of x's such that x happens to be a real number. So any number on the number line, if it doesn't mention anything about express it as a set, then in that case, you could just say infinite amount of solutions. So depending on how they want the problem, if it wants a set, you can actually rewrite it in that format or actually spell it out. So in this case, it'll be the set of x's such that x is a real number. In any case, well, this happens to be the infinite amount of solutions.